off, we were talking about K and Q. We talked a little bit about common ion effect, and we're going to talk a little bit more about that today. So if the system, if your K is greater than Q when you do your calculations, then that means that it's unsaturated. That means that you could put more solute in there and it would come apart as ions. If they're equal, then that's saturated. And if K is less than Q, then it's going to be super saturated if it's still dissolved. Otherwise, it would come out as a solid. Okay, so typically, a lot of times your metals, like your leads, let's see, other ones that are kind of heavier metals. Tin is another good one. A lot of those end up being insoluble salts. Okay, so when we're looking at these, we're going to determine like our precipitate conditions here. So we're trying to see if a precipitate will form in this solution. They've given us our KSP. So we've got two different ions that we're bringing together here. We have our CeNO3, and then the KiO3. And we're looking at the Ce part of this guy and the IO3 part of this one, because this is what we're trying to figure out if it's going to precipitate or not. Does that make sense? So for this guy, I'm going to figure out my moles. I'm going to figure out my moles over here of this material. Now, I'm going to take this, my 4.0 times 10 to the negative third, and I'm going to multiply it by 0.750 because I need to get this into liters. So multiply these two things together, and that's going to give you the moles of this material, which is also the moles of Ce because it's in a one-to-one relationship. So our Ce 3 plus, how many moles did you get for that?
0.003.
Okay. And my IO3 minus, we're going to take this, we need to move the decimal 0.3 spots to get it into liters, and then we're going to multiply these together. Since it's in a one-to-one relationship, however many moles of this material you have is the same number of moles of the IO3. So what did you get for your mole value there?
0.006.
Yep. Good. Okay. Now we need to figure out our molarity so that we can put it in and figure out our QSP. Trauma. Okay, so what is my, I need, in order to find out my molarity, I have to find out my combined amount of volume here. So I need to add 750 and 300, which ends up being 1.05 liters. Good. That's going to give me then the molarity of each of these things, which I can then sub in to this formula. So for this guy, he ends up being 2.86 times 10 to the minus 3 molar. And this guy ends up being 5.71 times 10 to the minus 3 molar. Double check my math, make sure that that looks right. Yes, ma'am.
So how did you get the moles for IO3?
The IO3, I multiplied 0.3 times this. So that gave me the moles for here. And then I'm going to divide it by the volume to be able to get my molarity. Now, when this breaks down, it's going to break down to Ce3 plus 3 IO3 minus. So when I put this into my QSP here to calculate that out, I'm going to take this guy and just write him as he appears. I don't need to alter him at all. I'm going to write this guy down, but what do I need to do to him once I get him written down? Right, take it to the third power. Good. And that's going to calculate out to be our QSP.
So do we not have to multiply by 3?
No, this has already taken that into account. This is the, you're not going to have 3. It's how much is present there. Okay. It just means when this hooks up, this needs 1 for every 3 of these. But this is the concentration. This is how much we have. All right. So when you get that calculated, you should end up with 5.33 times 10 to the minus 10. What are my units?
None.
None. It's Q. Good. Okay. So now we're going to look at our K versus Q. Well, our exponents are exactly the same. So then if we just compare 1.9 and 5.33, which one's greater? Q. So that means that it's going to go this direction. If it goes that direction, then it's going to make more solid. And yes, a precipitate will form. Anybody confused about any of that stuff? Did I lose anybody? Is your next problem exercise 6?
7.
I skipped to 7. So it says a solution contains. Okay. All right. All right.
Why would you ever take that?
So we've got a solution here, and this solution has got some copper in it. It's got some lead in it, and we're adding iodine in it gradually. They want to know if we added this or this, which one would precipitate out first, and specify the concentration of I that would begin to precipitate each salt. Okay. So if we look at the PbI2, we know we're going to get Pb2 plus I minus, but we're going to have 2 of those. Okay. So our KSP here, which is 1.4 times 10 to the minus 8, would equal, because this is the KSP of PbI2. Oh, I know, I got that. Okay, so if I sub in here, this value for lead, I've got that. So it's going to be 2 times 10 to the minus 3. And then we're going to represent this guy with X. So he's going to end up being what? 2x, and then what do we have to do to that? Square it. Okay? Now you're going to solve for x. All right. So x is going to equal what?
1.32.
Okay.
Or do you want that?
Standard for? Is that right?
X is the right here. It's the I concentration. But we need to multiply it by 2 by the time we're done, though. Because we have to figure out the I concentration. That's going to give us...
Is it already multiplied by 2 squared?
No, not when it's squared. No. Because you divided the 4 out when you... So you're just finding the X here. So this X ends up being 0.00132. So for the I, we would need 2 times that, which would be 0.00264 molar. Okay? Yep.
Concentration of I needed to precipitate.
Yep. If you're using this, if it was, they're asking you which salt would make it precipitate
Wait,
first.
why did we double it again?
Because you've got 2 of these. So when you're
Oh, I
solving
got
for
you.
X, you solve for X, but now you've got to go back and double it so you can figure out.
Even though you solve for x and use the 2, you have to re-put it back.
Yeah, because you took it back
Okay.
out. You took it out when you divided by this guy. You know, X is just X. Like,
Okay.
it's just one of those. Okay. So then we need to turn around and do the same thing now with this guy, but he's going to be a little bit easier because we don't have all the squaring and doubling and all that crap. So CUI, he's going to give us a CU plus 1 plus an I minus. So here we have 5.3 times 10 to the minus 12 equals, we know that our copper, they told us, was 1 times 10 to the minus 4, and this guy we're going to represent with X. So solve for X here, which is the iodine, and that ends up being 5.3 times 10 to the minus 8. So we have to add in a lot less of this than we do this. So the CUI will precipitate first. And this molarity is how much you would need to make that happen.
Wait, so why is it 1 again?
because primarily it comes down to the KSP values. Like if we didn't have this up here and we just had to like give a gut check, like a guess on it, this, because the number is so much smaller than this, would tell you right away that this guy's probably going to precipitate out first. Because the lower the number here, the less you can have that's going to come out as ions. The more this side of the reaction is going to be favored, the smaller that number is. And I think is that it for those? Do I have another? I think that's it for those. And we just flip over to, do we go to 5 or 7, 12 now? Okay. Thank you for going slow with me this morning. Still morning, yes. All right. So essentially, I've gone through a lot of this. We're just going to go through some of the problems here now. Did I blot any of this stuff out for you guys? Or did I leave it in there? Okay, good. All right. So what common ion means is when we are working with these, we end up having situations where we are adding in a substance to a solution that already has some of those ions present. So for example here, if we were looking at zinc hydroxide and we added that to a basic solution, that basic solution would already have some hydroxide ions in it. Okay, so that's what they're saying here. We've got a solution here, we're adding zinc hydroxide in, but we're adding it into a basic solution, a solution that already has some sodium hydroxide in it. Remember, this is one of your strong bases. So it's already got 0.1 moles, assuming we have a liter here. It has 0.1 molar OH floating around in there. Okay, so because of that, that's going to be a factor when we're trying to figure out, this is going to precipitate out a lot sooner than it would if this was just in water, because it's already got some of those ions in there. Okay. So you have to go with your ice chart again. You have to start out with 0 zinc, but we did have some hydroxide in there. Okay, that's where they're getting that value from. Then we know that we're going to form X and 2X. So this is already going to have some material in it. So when we go through and we calculate X, and you can use that calculator function if you'd like, that I showed you the other day, that equation solver. That'll make this go a lot faster. Otherwise, you can do it algebraically. But you could also look and go, oh, this has a really low KSP value. Yeah, it's probably going to precipitate out. Okay. So here we go. So write, first of all, a balanced equation for this. So we're going to have this guy. He's going to come out into Ca2 plus and OH. Why do we have this grayed out?
Because it's a solid.
Right, it's a solid, so it's not going to count into our KSP. We don't need to kind of mess with wasting our time on that side. Okay. This is in pure water here. Oh, no. Write a balanced equation in pure water, and then they are saying that we've got some stuff. Okay, sorry. All right. So I've got this. I'm dissolving this in 0.2 molar calcium nitrate. So I'm already going to have some calcium in there. And since this is in a 1-to-1 ratio, and I've got one of these for every formula unit, that means that this guy is going to be 0.2 to start with. All right. Will we have any hydroxide to start with? No. Okay. Now, we don't know the rest of this. We just know that this is going to be X. This will be 2X. This is going to form 2X. This is going to form 0.2 plus X. So when we set this up, we're going to have our KSP, which was given to us in the problem. That's going to equal 0.2 plus X times 4X. Oops, not 4X. Sorry. I guess if I want to do it in my head there, then I have to erase. 2X squared is 4X squared. Does that make sense?
Yeah.
I just did that. Instead of putting it out there, I did it in the head. All right. So then we need to put this in. This would be a nasty little quadratic if you wanted to like spend the time doing that. Otherwise, if you have your equation solver, you can end up solving for X. X will end up being 0.0013 molar. They're not going to have anything on the AP exam where you need the quadratic, though. So they will have all of that solved for you. So you don't have to worry about that. So that's the molar solubility. When they ask for molar solubility, they're asking for this, for the X value for this equation. All right, questions on that? All right. So now we're figuring out the molar solubility of this guy. We've got our solution already has sodium chloride in it. So we've got AgCl. It's a solid. It's going to form into Ag plus Cl minus.
How do you get to the equation thing on the calculator, Libby?
Math, and then the up arrow, and it's like something solver. Math up, yeah, it's letter B. It's numeric solver.
Okay.
So,
Thank you.
yep. Do you need me to give you a second to finish that one up? So before I start this one.
Oh no, I'm doing this one.
Okay. All right. So this guy, we're starting out. We've got sodium chloride. Our sodium chloride, remember our formula for that is NaCl. So for every 0.001 molar of this, I have 0.001 molar chlorine. So I'm going to put that over here because I've already got that in solution. I don't have any silver to start with. I'm going to add X here. I'm going to add X here. So this is going to be X and 0.001 plus X. So my KSP then is 1.8 times 10 to the negative 10 equals X times 0.001 plus X. And so then you just solve for X.
Wait, Loopy, did you figure out how to fix the calculator with the equation solver?
Yes.
How do you do it?
So when you type in your thing and you hit solve,
Yeah.
and it comes up with like x equals, type
Yeah.
in a couple zeros there. And then hit solve again.
So, 0? You press the graph. I'm such a genius. I learned how to use an intel.
And then it should already be in there, and then hit OK. Put 0 there, and then hit solve. And then there's
Oh.
it's the same answer.
Okay. Wait, yes. Wait, do you wish you told us to do it? With like zeros for x and then for 0. Okay, that
This
makes
Lippy,
sense.
I mean, oh.
That's your question.
I watched a video.
Yes, Lippy, you're so.
What I do, I go.
Okay.
What's it called?
Resourceful.
Has that? Okay, I
Either
can do
there.
that.
I don't know why. I just know it works. I can't tell you why. I just know it works. That I don't know. The Uber calculator, I don't know.
You're so taken.
I can help you on these newer ones, but the older ones, I don't have much.
Graph. 0.
I know. I could quit.
Like you make.
Oh.
All right. Questions on this guy? Does this anything not make sense here?
I get it.
All right. All right. So tonight, is 7:12 then, okay?